to you.
Good morning and good afternoon to all those who are watching. Thank you for giving up some of your time to listen to and watch this lecture. I hope you find it's interesting. So I emanate from the field of human spaceflight, but I work now for Blue Abyss. We are developing large infrastructure for multiple sectors that work in extreme environments. One sector, of course, being the space sector. And what I want to tell you about over the next 25 minutes is the field of spaceflight preparation and how it's changing rapidly and significantly. And with no further ado, therefore, I will move forward with the slides. So spaceflight preparation in the years ahead is going to be primarily commercial. It has traditionally in the past been a government-led activity. It will be commercial. And I'm going to talk through this with these following slides in three segments. The first being the clients, the spacefarers, the people who are going into space, who are traveling to space. The second element being the issue, the problem, if you like, which is as a result of the nature of the changing clients who are traveling into space, and then the solutions, what is happening and what needs to happen about this. So the people who go to space traditionally, we know, are astronauts, these superhuman beings who are very highly selected. They go through detailed medical and psychological evaluation during selection. They themselves invariably are highly trained in one or two technical fields before they even become astronauts. So these are individuals who, by the time they're selected, are highly suitable for the rigors and the difficulties of spaceflight. Astronauts, as I'm sure most of you watching will be very aware of, go through a great deal of training over a long period of time. There's a lot that they have to absorb, a lot that they have to understand, and they have the mentality and the capability to absorb this massive amount of information very quickly. And it's people of that nature that are required because of the difficulty and also the risks of space missions and spaceflight in general. But the nature of the client, the nature of the people who are flying to and spending time in space is changing. We've now got career commercial astronauts who invariably are ex-government astronauts from space agencies. But they've finished their government career and have now started upon a commercial career. And as a result, they do tend to be a little bit older. And we have other spacefarers, as we have seen from the news, that have got different technical backgrounds. So here we've got the recent expedition, or sorry, the recent mission where we saw the civilian EVA, the civilian spacewalk. That's Polaris Dawn. So these individuals have got a variety of technical backgrounds on the whole, but not all. And then we've got the likes of suborbital flight. Suborbital flight is touching the edge of space, and a lot of individuals who have been participating in these flights are a lot older than typical astronauts. Many don't have technical backgrounds. And one of the things that we see in a lot of these new spacefarers, these spaceflight participants, is that they aren't, of course, selected. They have chosen to and paid to go to space. So the nature of spacefarers, this nature of people traveling to space is changing. They're older on the whole, less technically trained, and very often not selected. And some of the forms of, or the means of getting into space that are coming down the line, here we see space perspectives, are cheaper and will enable a lot more people to travel to space. And so the numbers of this type of individual, which is the general public in many cases, and I'm a member of the general public now, is increasing and will increase. And one of the aspects of this, if we consider the age of so many people now who have and will travel into space, is their health conditions. 40% of older adults have got at least 2 chronic health conditions. Here are the top 6 or 7. One spaceflight participant in the past had a number of conditions, and you can see 4 listed there. So we're going to see in the years ahead people flying into space with these conditions, and indeed with many other conditions. Here are the top health conditions for people who are over 60 in the Western world. Astronauts in the past are so healthy and maintain their health to a degree that these conditions have not needed to be dealt with. We've got a pretty good grasp of how space affects very healthy, moderately young individuals and what countermeasures and training and mitigation to use. But what are the effects and what are the impacts of these effects on a variety of health conditions? Let's take a look at some examples. If we look at arthritis, for instance, space is a physiologically inflammatory environment. So space will have an impact on somebody with arthritis, on their performance. It'll affect the nature of the training they will need to do and the preparation they'll need to do. It may affect the nature of the countermeasures they need to use. If someone has asthma, that's triggered by airborne irritants and strong emotions. Both of those things are evident in space. And so there could be an acute health impact with someone with asthma. The necessary preparation would need to include how would an emergency, an asthma-related emergency, be dealt with, and therefore the right trainings, appropriate training would be required. Cancer. Recent research has shown that cancer cells rapidly grow in space. This is a chronic condition, but there are individuals who may choose to go to space despite the fact that they know they've got cancer. And so there can be an effect. The right preparation would be needed, the right medications would be needed. Deep vein thrombosis. This has been seen in recent years in astronauts. These are super healthy individuals. We can expect it, therefore, to be seen in less healthy individuals. There could be an acute event there. The right medications are needed and the right response, emergency preparation and training would be required. So many new training programs and many new mitigations are going to be required in the future, and not just for people who are medics or involved in the medical world, not just for the astronauts themselves, whether they be commercial or government, but also for the spaceflight participants who are there to enjoy potentially if they're on a space tourist mission, for instance, or it could be a scientist up there conducting science for a few weeks or a few months. So we need more effective, potentially newer forms of mitigation, and these mitigation could be medication, of preparation, that might be pre-flight activities, including training, of facilitation, habitat design. The image you see there, you can see everyone is orientated in the same way. Typically when new crew enter low Earth orbit to a space station, everyone orientates themselves in one direction because that helps minimize space motion sickness. We need to understand the issues before we can apply appropriate solutions. The Human Research Programme, HRP, has been going for a number of years, and this is the program that has enabled us to properly understand what happens to astronauts and how we deal with those effects, what are the right countermeasures and what's the right training, etc. We need something similar for the new spacefarer, for civilians, if you like, then. And this has recently been started. It's called HRPC, Human Research Programme for Civilians. And this was started a few years ago by a speaker that's spoken on the conference today, Michael Marge. And a number of us have been involved in the last couple of years to help produce a roadmap, which was discussed and debated at a workshop in January, and from which a report has been produced. And this activity has led to the incorporation of a not-for-profit organization to help organize, coordinate international research into the effects of the space environment on this variety of health conditions that we've looked at, and to better understand where are there gaps in our knowledge, Where aren't there solutions and countermeasures? What countermeasures and solutions already exist and can be used? And what do we need to work up for the future? So if we look at training and countermeasures, we've got to move from where things are today towards what is going to be required for a much larger number of heterogeneous individuals, a group of individuals with a variety of backgrounds, where the training and the countermeasures will take into account the different qualifications, the different abilities, health conditions, the different technologies that are available. If we look at countermeasures, we can see the evolution of countermeasures over the last few decades to where we are today. And we've got a number of countermeasures that are in the pipeline now, which are the new generation of countermeasures. And these do abide by the specifications that we traditionally use: low volume, small mass, low power use, small footprint, easy maintenance. All of that is required, but also the new generation needs to be considerate of the fact that there will be elderly people using, not in every case, but for those who are spending longer periods of time in space. It could be space scientists, it could be industrial workers, for instance. That these new countermeasures need to be able to be used by people with a variety of health conditions, with a variety of abilities or disabilities, from different cultures, and they'll need to be highly durable if they're to be up there to be used by a lot of people over a long period of time. Or we could look at, and I personally think this is coming, it will be a magnificent form of countermeasure one day, and that is artificial gravity. Artificial gravity means that a great deal of the deconditioning that we see as a result of being in space, the deconditioning of bone, of muscle, changes in blood pressure control, these will not happen or will be greatly reduced. And as a result, a great deal of training and preparation that's typically undertaken today won't be required. There are different concepts that are proposed. Here's a SpaceX concept for artificial gravity. We don't know at the moment whether it will definitely happen. I think it will, but when it will happen, we don't know, and what concepts will be pursued and adopted. But suffice to say that when it does happen, it doesn't mean that life will be exactly the same as we encounter on Earth. Here you can see some individuals in a centrifugation project, and things are a little bit odd, as you can see. So even with artificial gravity, there will need to be the right preparation and the right changes. Let's look a bit more at training itself, and the programs adopted, the programs employed by the commercial sector will need to be appropriate for older people, will need to be appropriate for, as already mentioned, clients with a variety of health conditions, need to be appropriate for different abilities and disabilities, for the different cultures that will be flying into space. And there will be a broader range of needs with respect to multiple factors that require training and preparation. Now, these elements here are covered in current government training programs, but they'll need to be covered in a way that will be suitable for the new spaceflight participants, the new spacefarers coming down the line. Cognitive, physical, physiological, medical, skills related, procedural, and I've underlined psychological. We're going to have, remember, a great deal of individuals flying into space who haven't gone through a selection process, who haven't been screened out to be suitable for the stresses and rigors of spaceflight. There will be many individuals who will be flying into space who may be doing so, but apprehensive. So one of the key things that will have to be prepared and trained for will be the psychological component. So I think there will be a lot of training programs that will be individually tailored for individuals and for groups. because there'll be a great number of components that will be chosen from, will be able to be used for these programs. And we shouldn't forget rehabilitation. If a number of weeks or months has been spent in space, then we don't come back and then go straight into our normal everyday activities. We actually have to rehabilitate. Astronauts rehabilitate for a number of weeks or months, depending on how long they've been in space. And the necessary rehabilitation programs will be required. Training government astronauts and candidates in many ways is the pinnacle of capability in this field today. But if you think about it, the breadth of knowledge that's going to be required, that will be needed for preparing this broad scope of civilians who will be traveling to space, that breadth of knowledge and those skills will be much greater in the years ahead. So virtual reality is something that we are all very familiar with now, and that's a great tool for preparation and training, where the reality, the real environment, needs to be replicated as best as possible with virtual reality as a training tool. Here's an example, and this is a NASA example. I believe it's a virtual reality tool under preparation. And the fidelity needs to be high, and indeed is high. And of course, with virtual reality, we're using our eyes, we're using our ears, we can hear and we can see. Our human interface technologies team has produced a version here, a virtual reality version here. And whatever VR we're looking at, there needs to be the parameters of the space mission, of the space activity involved, the objectives, the necessary activities that are going to be undertaken to optimize the training and the skill retention and knowledge retention. But we don't just want to use eyes and ears. We need to use all of the senses. And there is technology and there are processes that can be and are used to augment virtual reality, to take us into augmented reality and mixed reality, to take the fidelity up closer to the reality of the activities. And these are important to have a better training product. One system, one concept that our partners are working on is a cobot system, which will be a step forward from traditional offloading training systems, which will use multiple robots to enable a situation where there is effect and reaction between two different bodies to be replicated, so that the individual being trained feels, not just sees and hears, appropriate reactions, and as a result has a better training tool for their training program. So we've talked about virtual reality, we've talked about extended reality, and we've touched on the NASA VR Mars simulator, and we've had a bit of a clip of that. But we need to take things further forward, and NASA is indeed doing that, and look at a space metaverse. So a space metaverse would actually include all of the elements, all of the teams and the different locations involved in a given space mission. Mission control, launch control, the vehicles used, the training programs, the training analogs, sorry, where the crew is. So a metaverse enables multiple teams to be trained not only individually, but also together to prepare for space missions. So let's move on from the training tools and the training programs to facilities. Blue Abyss, as I mentioned at the beginning of this talk, is building very large facilities, not just for the space sector, but also for offshore energy, for marine defense, for multiple sectors with aligned needs. But the space elements in these facilities require an aquatic complex at its core, require a high G component, require a low G component, in our case, subsea pressurized habitats, and mission control aspects. So these all brought together in single facilities and a single location. where the centrifuge, long-arm human centrifuge, is able to replicate the acceleration forces of launch and return, not only enabling training, but also research, where the zero-G component offers hypo, that's Moon and Mars, of course, and microgravity training and experience, and where the necessary education facilities are one, appropriate for the new age of spaceflight, and two, present within a single facility. So we're going to see a sector, we're going to see a field of endeavor where there are space camps, where there are collective partnerships. We've already seen a NASA SpaceX partnership, where there are diversity of training providers, ourselves, some of the new space companies are already talking about and providing elements of training, where there's a personalization of training programs possible, where advanced facilities and simulation technologies are used, and indeed where there will be certification programs for these civilian training programs and mitigation solutions. So there we are. We are talking about an evolving sector. The new paradigm with regards to spaceflight spaceflight preparation, is that we will be preparing a large number of heterogeneous, less healthy people to go to space, rather than the traditional small number of homogeneous, super healthy individuals. And where the sector is going to be characterized by rapid growth, by greater accessibility, by a wider array of preparation and mitigation and facilitation means to enable this new spaceflight community to travel to and spend time in space at minimal risk and with optimal performance and enjoyment. So with that, I'll thank you all for listening, and I'll stand by for any questions that you might have. Thank you.
Wow, thank you. That was a great presentation. So I don't know if someone in the audience wants to make a comment or a question. Right now we don't have any, but we can wait for 1 or 2 minutes to see if someone wants to share.
If you get some questions, Mauricio, I'm very happy for you to pass them on by email, and I'll reply by email.
Yeah, of course. That will be great too. Okay. So yeah, thank you again for your wonderful presentation. Thank you for all the attendees too. And yeah, we invite you to continue here in the space conference. We will have a 10-minute break and see you on the next sessions. Okay. Thank you for everything. Yeah.
Thank you. Bye-bye.